Hello, and welcome to this first and probably only video in my How to Excel series. As you may already be able to tell, the topic for this video will be the popular board game Monopoly. It's a killer way to ruin an evening with friends, and an even better way to abolish friendship altogether. Either way, there's no doubt it's a pretty great game, but it's definitely more fun when you're the one winning. And so that's what we'll be trying to achieve with today's video. I'll be starting us off with a quick overview of what I want to cover, and I'll also make sure to pin the timestamps for each topic in the comment section, right down below that like button, so you guys can skip all my hard work and go directly to the summary at the end. So, let us start by briefly talking about statistical data, and a distinction that I want to highlight is the one between coincidence and correlation. All the results presented in this video will be based on long-term probabilities. That means that all of the probabilities are derived as averages from very large data sets. As a quick example, I'd like to address this sequence of dice rolls. These are the values I got from rolling 2 dice 3 times. Now, would it be accurate to use this information to conclude that 12 is the most rolled value from 2 dice? Well, you may already know where I'm going with this, and of course, no. This is not nearly enough data to make any accurate assumption on the probability distribution of rolling 2 dice. But by continuing to roll the dice and computing the average value of all of the dice rolls, we can eventually find the correct expected value. And for 2 dice, the most likely value is 7, followed by 6 and 8. And this is really useful information to have when making decisions in game. I assume you're all mostly familiar with the contents of the game, so I'll just give it a brief mention. Because in jail and just visiting are defined as 2 separate squares, the board has a total of 41 squares. 28 of these are properties that players can own, while the rest are either chance, community chest, or other squares like go and income tax. Taking a closer look at the chance and community chest squares, we see that the game includes 16 cards of each type. Drawing a chance card, there is a 63% probability of being moved to a different square, but drawing a community chest card only has a 13% probability to move the player. There are 36 houses and 12 hotels included with the game. These are supposed to be available only in this finite amount. So, if there are no more houses in the bank, players can't improve their properties. Lastly, here is a list of all of the properties in the Norwegian version of Monopoly and their respective color sets. Up next is the section on simulated play in Java, and we are about to see that some properties are a far better investment than others. So, here is the main section of the code I wrote, and quite simply what this method does is loop one player's turn for a finite number of turns and records the movement of that player. Notice how the position of the player is updated at the end of each turn. Of course, I also had to define some sub-methods to make the program complete. And most importantly was the methods for drawing cards. Here you can see all the different chance cards that move the player. And here are all the different community chest cards that move the player. Then, after a simulated 10 million dice rolls, I ended up with this estimate of the probability distribution. These models show the probabilities of ending up on each square and the relative ranking of each square's probability. The squares outside of the board represents in jail, and the boards are oriented such that the bottom right square on the model is the go square on the Monopoly board. We see that the most visited square is in jail, and the most visited property is Slamdal, or Illinois Avenue, in the American version of the game. The top right corner is go to jail, and notice how this square has a 0% probability. This is because the player can never end its turn on this square. Even though this is a very good approximation, we can do better using Markov chain methods. We can arrange a transitional matrix describing all the possible states of a problem and then iterating this matrix on itself enough times to find the steady state of the problem. Looking at this very simple A-B example, we can easily compute the transitional matrix. From here, simply multiplying the state with the transitional matrix will eventually converge to the steady state solution. We will start to solve the Monopoly problem in this way by looking at a simplified case. This case disregards jail, chance and community chest cards and it is clear that in such a model the motion around the board is determined by the dice rolls alone. This distribution is the same that we saw earlier on for the dice roll, only now it's fitted around the board. Doing more dice rolls changes the probability. The transitional matrix is set up such that the initial dice roll distribution applies to every starting point, and then it's iterated on itself. Knowing this, we are ready to look at the complete Markov transitional matrix for the Monopoly board. This includes chance cards, community cards, and of course, in jail and go to jail. Iterating the full transitional matrix eventually gives us the exact solution for all the probabilities in Monopoly. Once again, these models show the probabilities of ending up on each square and the relative ranking of each square's probability. The squares outside of the boards represents in jail, and the boards are oriented such that the bottom right square on the model is the go square on the actual Monopoly board. We still see that the most visited square is in jail, and the most visited property is Slamdal, or Illinois Avenue. We also get a confirmation that the orange and red color sets are the most probable color sets in the game, while the brown is the least probable. Now we have all the information we need to start our economic analysis of the game. Starting out, rent and rent cost ratio are produced by information available on the cards themselves, on the property cards, while expected return and rolls to recoup incremental cost are computed using probabilities for each square. So, these models show the rent on each property, from just the street alone up to the 5th improvement, which is a hotel. The model on the right takes this rent and divides by the total amount you paid for the street and improvement. Notice how 3 houses appears again to show a cost efficiency sweet spot. These are the expected returns on each property on each opponent roll. The numbers for the railroads and utilities also include cards that grant double rent. I encourage you to pause the video and familiarize yourselves with these numbers. Lastly, using the numbers for expected return, we can compute the expected number of opponent rolls to recoup your incremental costs. To improve readability on the model, I've aggregated and averaged the rolls to each color set instead of each street. Once again, it becomes apparent that the highest efficiency on your investment is when improving to 3 houses. Also, we see that the orange color set has the lowest payback period for this improvement. So, with all of that out of the way, it's time to move on to the grand conclusion of this whole video. My key takeaways, my 5 tips for you to start winning at Monopoly. Number 1, know your dice. 7 is the most probable outcome at close to 17% probability. And 44% of the rolls will be either 6, 7, or 8. So if an opponent is between 6 and 8 squares away from a street that you own or a color set that you own, you should really consider improving the streets in that color set. Number 2, buy as many properties as possible early on in the game, even the less probable ones. So this one is kind of obvious. Getting properties early, first of all, prevents your opponents from getting them, but it also improves your expected wealth during the course of the game. Number 3, orange and red are the best color sets in the game, with Slamdal or Illinois Avenue being the most probable property. Orange also has the lowest payback period for 3-house investment, while red has almost the same but generates a higher expected income. Number 4, 3 houses strategy. It's generally best to improve a color set to 3 houses as fast as possible. This has been apparent in all of the models, and this is a really key strategy. The last, take advantage of jail. Stay in jail for as long as possible in the late game and pay your way out of jail right away in the early game. Spending time in jail early really puts you at a disadvantage, while in the late game, spending time in jail, you can't land on other people's properties, so you won't have to pay rent, but you can still collect rent. So this is also a key piece of strategy. So, that's it. I will thank you for your attention, and I've had fun making this video, and I've had fun exploring the probabilities and the math behind Monopoly. And I hope you have enjoyed watching this video too, and that it didn't end up being too long. So, thank you.